Gentlemen, I'll be right with you. Just give me a moment. Okay. Not know where that adapter is. All right. Let's see. Let's hop here. We're done there. Let me share my screen. Start the broadcast. Okay. And let's go here. Where is my phone? All right. Join. Come on. Join. Okay. Participants. Go off. Oh my God, thank you. Whew. All right. So at least I know my audio's working, right? One more thing. Let me change my view. Single page. And I think we're Gucci. All right, gentlemen. Let's see. So one, I hope everyone had a great weekend. You enjoyed your weekend. It was productive and got things that you needed done. Let me see. So one, today I am using my microphone. So that means that I can't hear your audio today. So if you have questions, feel free to either type it in the chat or put it in the Q&A. And because I am monitoring those, I'm just, monitoring the whole thing. So I can see that stuff. Let me see. So the main things, the meat and potatoes of what I'm looking for from each of you. One, be sure that your username in Zoom is your full student name. So your student first name and last name. And I think everybody in this class is okay. I think it was just my earlier class. I had one student whose username was Zoom user. So, they weren't getting credit. I had to do like detective work to try to figure out. You don't want me to have to do detective work because I'm not a good detective. All right, because I'm not going to find you. So make it easy for me. Show your student name, and then so the meat and potato in Zoom. So the meat and potato that I'm looking for each of you is basically attendance credit. I try to make attendance fairly simple and easy. You just show up and to the Zoom like you've been doing with your student name showing, and then you can zen out. I don't hound you guys. I don't press you. I'll ask questions, but I try not to single people out. So as long as you're here and you're zen, allow me to kind of just get through the material and people can ask questions that are paying attention. That's all I really request. I try to run everything. I treat you guys like you're an adult, right? Because you are an adult. So I leave the space for you to decide for yourself, right? How you're gonna go about this. You have to decide for yourself and make a plan and take action. All right. If you decide not to decide, you have to live with what comes with that. If you decide not to pay attention, that's on you. Right. My job, I'm just here. I make myself available, answer questions. I try to make it as fun as interesting as I can, but sometimes I just be like, I just want a game. That's all I really want to do. Half the time, half the time that's why I'm late. So I was a little bit late today. I had to whoop up on these opponents, man. It's the game. There's a whole saga, man. I need to start logging like some of the psychology there because it's like a soap opera. It's like a 30-minute soap opera every time you play a match. It's so much fun. You're constantly battling like ego and strategizing. You're playing less against opponents and more against your teammates. Like you got to trick them and try to account for like trolls and noobs. Man, it's so much fun. It's really interesting. But okay, so attendance, and then the other thing that you're responsible for are the assignments in my math lab, right? I think this section does not have a lab component, so you're good there. But yeah, so just get your daily attendance by showing up to the Zoom with your student name showing, and then just make sure that you're submitting your assignments on my math lab promptly. So this week we're going to be working or focus on, let me see if it's here, section 1.3. Why does it look like that? Can we change that look? Whatever. I guess we just have to work with that. 1.3 functions. And so basically, I think we said that every 3 sections we can anticipate an exam. So what that means is we can anticipate exam 1 to become available this Sunday, Sunday, right? At 11 a.m., right? So I think it's available this upcoming Sunday, and it's available for 7 days. Now, during exam weeks, those are fairly light. I might take like one day to review. The first, like Monday, I might review. And then Wednesday, I might hold like class time is just unofficial office hours. So I'll just show up. You get your attendance. If you don't have any questions, more than likely next Wednesday, I'm not going to keep you. I really devote the entire week to the exam. Now, you can actually take your exam during class if you want, and if you have questions, you can ask during class. We can work on it live together. When it comes to the exam, you get unlimited attempts, right? And the system is set to take your highest score. So, again, when it becomes available this weekend, give it a go. If you need some help, you can ask during class, and we can actually work on it together, and it'll be okay. Okay, so I think that's the meat and potatoes. So yeah, again, if you have questions, feel free to either type it in the chat or put it in the Q&A, because I am using my microphone today, which means that I will not be able to hear your audio until the end of class. When our exams do end, I think that's a typo, but exams are, you can access them for 7 days and earn full credit. So they're basically due a week later. But keep in mind that all of our assignments, we get unlimited attempts. The system is set to take your highest score, and there's an automatic extension built into the assignments, right? So even though it's due 7 days later, you can submit it past the due date and still earn up to 95%. The hard deadline for all assignments is the end of the semester. Like, I think it's like that Friday, December 13th. I may have pushed to that Sunday, December 15th is one of those 2 days, right? But if you try to get everything by that Friday, that second Friday in December, I think it is. That's the hard deadline. These soft deadlines along the way, there's a 5% late penalty if you submit something late. All right, these are good questions. Okay, so we'll do the best we can to get through as much of this together. And again, whatever we don't finish together, I do expect you to use my recordings to fill in. And there's some examples towards the end that you definitely want to take a look at. More than likely we won't have time, but you never really know how these things are going to unfold. So, okay, so here we're looking at section 1.3 functions, and we have a few objectives. 1, use functional notation and find function values. 2, find the domain of a function. 3, identify the graph of a function. 4, get information about a function from its graph. And 5, solve applied problems by using functions, okay? So we have some definitions. A special relationship such as y equals 10x, in which to each element x in one set, there corresponds a unique element y in another set. We call this a function. Y is sometimes referred to as the dependent variable and x as the independent variable. All right. Okay. So basically a function, the general setup is like, we have a set of input values. We call that the domain. And then the function, what it does, it takes each input and then maps it to some corresponding output, right? So like in the one that's shown kind of towards the top, y equals 10x, x is an independent variable. So we tend to just choose different, multiple x values, pass them through the function. So like when x is 1, 1 times 10 is 10. When x is 2, 10 times 2 is 20, so on and so on. It's generating that set of output values, right? So that's basically what functions are. Input passes through the function generates a set of output values. Okay, so then a function from a set x to a set y is a relation in which each element of x corresponds to one and only one element of y. Okay, so every x corresponds to exactly one y. Okay. So with a function, each x corresponds to exactly one y, and there's a little bit more to that, but we're not there yet. So we'll leave it there for now. The set x is the domain of the function. It's the set of those elements of y that correspond or assigned to the element of x is the range of the function. Again, domain is just our set of input values, and the range is our set of output values that we generate. Okay. More terms and concepts. Let me see. So for each x in the domain of f, there corresponds a unique y in the range, right? Not multiple y's. Notice emphasis on that word unique, right? So for every x in the domain, when it's a function, there corresponds one y, not multiple y's for each x, right? The number y is denoted by f of x and is read as f of x or f at x, right? So with that, right here, this guy, this is read f of x, right? This means the function x, the function f evaluated at the value x, right? Sometimes when students see this, they think that we're multiplying by x, so that's a common error where students will distribute an x. We're not multiplying x by x here. This is not multiplication, okay? This is function notation. The function f evaluated at the value of x, okay? So it's not multiplication here. That's, so we call f of x the value of f at the number x and say that f assigns the f of x value to x, right? Okay. So a little bit wordy, but, pretty much for your entire mathematical experience, you'll be working with functions. So eventually it'll sink in if it doesn't sink in immediately. Hopefully you all, have a group me going and you've connected with the tutors. Yeah, let me see if I can pull that up. I tried to save it and I think I accidentally cleared it out. Let me see if I go like this, is it there? Yes, there it is. Let me see, tutors, Dansby, is this a PDF? Yes, I think it is. Can I get a copy? Where is it? Nope, it's not a PDF, but that's okay. All right, so what I'm gonna do, I can get this out of the way. Okay, that's a little bit better. I'll just screenshot it. Does he have a number? He does have a number. What if I turn it sideways? Does that make it any better? New. That is like really irking me. How can I get rid of this? All right, we'll go through this. So basically, I got an email, I guess it was sometime last week, about the tutoring. So I'm just including it in these notes as a screenshot. The notes. Yeah, that's the other thing. I got to figure out how to get it to you all because however I was doing it before, the admin has disabled it and it's like throwing a monkey wrench in my and the things that I do. Let me see. Can I just paste? Nope. Nope. Undo. Let's try that again. Copy. Oh, does that work? No, that's not any better. Undo. Let's try this again. Copy. Paste. You just refuse to cooperate today, huh? I have this kind of issue. Let me see if I share. What if I airdrop? That's what I was trying to avoid this. I'd rather copy and paste, but the handoff seemed like it's not working today. Come on. This is frustrating. Okay. So let's hop back. Let me see. Here. This one. This one. Okay. All right. That's all I wanted. All right. So I'll just include this. It's probably a good idea to like screenshot this until I can figure out. So this is just information on the tutoring. Let me see. I can make that look a little bit more presentable. So what I'll do, let me duplicate this. And what I'll do is just cut this. I'll include it kind of towards the top. Paste. I did not get an opportunity to share this with my earlier group, so I just thought about it now. That's why I was saving it. Okay, so if you want to screenshot this, it's there. And at the bottom, I left. I think that's the number to the department chair if you needed to call him. Yeah. because like, I would imagine that there should be a way to contact them remotely, right? That's what I'm trying to get you guys to. Anywho, is that it? What is that? Okay, how do I get rid of this? Delete. Okay, I think we're back in business. Okay, so that was there. Okay. So now let's see. Let me see. So functions can be defined by ordered pairs, tables, and graphs and equations. Okay. So in this example, we're actually determining whether each relation defines a function. So a moment ago we said that a function is where what each x corresponds to exactly one y or unique y, right? So let me hop back here so I can see. Done. This one. All right. Okay. All right. So if when it's given like this, long story short, if we have repeating x's, then it's not a function, right? So in the first one, do we have repeating x's? Yeah. All right. If we were to plot these ordered pairs would be stacked on top of each other, right? So whenever you have points stacked on top of each other, then it's not a function. The domain of the first one is going to be a set of input values. So that would be -1, 1, and 5. The range of the first relation would be the set of output values. So that would be 2, 3, and -3. Okay. The second one, do we have any repeating x's? No. All right. So then it is a function. Our domain, a set of input values, right? And our range or our set of output values, right? So again, we said the first one is not a function, and you see the domain and range listed there. Notice with the domain and range, they listed out the unique components, no repeats, right? Okay, but we said that this was not a function. And then we said that part B is a function. Okay. All right, so I think we had a typo here. Determine whether y is a function of x for each equation. The first one is really supposed to be 6x squared minus 3y equals 12. Okay. So then what we can do here, let's see if we can get y as a function of x or y in terms of x. So in other words, let's see if we can solve for y. Okay. I think I'm going to add 3y and subtract 12. So if I add 3y to both sides and subtract 12 from both sides, okay, I'll go back in just a moment. So add 3y and subtract 12, 6x squared minus 12, okay? We can divide both sides by 3, 2x squared minus 4, right? So then if it's in this form, one thing that we can do is, well, this is y as a function of x, right? You can look at the graph. I think with my earlier group, we did a demo on Desmos. So let's do something similar here. Didn't mean to do all of that. Come on. Let's try this again. Okay. So is it still open? No. All right, so let's do a demo on Desmos. There it is. Go. It's basically a free online graphic calculator. So with the first one, I want to try just typing it in the way it was given and see what happens. All right. So we got 6x squared minus 3y equals 12. Okay. Yeah, and that is the correct graph. Okay. So yeah, that type, because when I tried this with my earlier group, I was like, why is it showing up so weird? Because it was a typo in the original part. So we fixed the typo. Okay. So now notice this. Every x corresponds to exactly one y. We don't have any points stacked on top of each other, right? So all we did was type the original into Desmos. We got a proper image. Okay. So then is the first one a function, is y a function of x? We would say yes. We just looked at the graph. Okay. But then for B, let's just do the same thing. Let's just look at the graph and see what happens. Actually, before I do that, let's try to solve y in terms of x. All right. So if we try to solve for y in terms of x, right, we can add x squared to both sides. We'll get x squared plus 4. To get rid of that squared, let me get rid of this so I can see. Yeah, okay. So to get rid of the square, we take the square root on both sides. And whenever we introduce square root, we should also include plus or minus. Whenever we do an even root, like fourth root or sixth root, any kind of even root, we include plus or minus. Okay. These guys cancel each other out. So then notice here, if we choose a value of x, for instance, if we let x be 0, right? When x is 0, 0 squared is 0, plus 4 is 4. The square root of 4 is what? 2. So then when x is 0, the corresponding y is plus or minus 2, right? So notice that one x corresponds to more than one y. A dead giveaway is basically because we have the plus or minus. That essentially means that we have, it's not a function, right? It's not a function. One x corresponds to more than one y. So this one is not a function. If we were to look at the graph, we're going to see points. We should see points stacked on top of each other. Y squared minus x squared equals 4. Y squared minus x squared equals 4. Okay. And yeah, I think this graph is proper. Notice we have points stacked on top of each other. So it's not a function. All right. Okay. Let me just confirm. I think this is good. So I'm going to kind of let that be. There was a request to go back to the previous slide. So, okay, with these couple of examples in the previous one, the simple way to kind of summarize it is, if there are repeating x's, then it's not a function. For instance, with that first one, if we were to plot those ordered pairs, we start at the origin, we go left 1 and up 2, and then that last one we go left 1 and down 3. Those two ordered pairs are going to be stacked on top of each other. So whenever we have points stacked on top of each other, is not a function. And then b is a function because every x corresponds to exactly one y. Okay. And then the domain is our set of input values, right? So these are ordered pairs, so basically all the x values. Our range is our set of output values. Okay. Let me, nope. Not there? Okay, that's okay. That would be nice if I could have multiple open. Answer live. Like, and noise. Okay. Close, and let's keep the party going. All right. I really appreciate these like 50-minute courses. Like, you blink your eye and it's like done. Like, we're already halfway through. Party's almost over. What a bummer. Does anybody know where I got that little phrase from? We're halfway through. Party's almost over. What a bummer. I'm just curious if you would know that. I don't really want to tell you. I'm just curious if anybody knows where I'm getting that from. Okay, so these were good. And it's kind of obscure. Like, you really wouldn't necessarily know that. Okay. All right. So in this example, we're given that let G be defined by this equation. Let me see my time. I think they gave it as y equals x squared, which is fine. But since we're saying G, I just changed it. Instead of writing as y, I wrote it in as a function as g of x, right? So we have this function g of x equal to x squared minus 6x plus 8. And we want to see if we can generate these results. I'd like you all to take 5 minutes and just try to get as far as you can in these examples. And basically, the first 3 parts, we're just evaluating this function. We're just plugging in, right? Replacing each x with those values, generating an answer. So give it a go, and then see, and maybe go ahead and try to attempt D&E as well. Hopefully 5 minutes isn't too long. Hey, Google, set a timer for 5 minutes.
Got it, 5 minutes. And that's starting now.
Let me see. And then here, I'd like to do no. go copyright. Yes. Let's see what we get this time. All right, let's just try this. Okay, that looks decent. Now it probably won't show up in my stream because I'm not feeding the audio. Maybe I could feed the audio. Do I want to do that? No, I don't. I'll just pull it up here. But just take a moment to see how far of these you can make it. That probably will be a little bit better. There it is. Nope. Where'd it go? I think this is it. Okay. We're gonna get this one to go. Yeah. Uh-oh. Oh. All right, so we'll go. I'll give you until about 2:30, give or take. Just take a moment to see how many of these you can answer. I need the views to push me to a new abuse of being used. Everybody wants a piece now. Don't the rest in peace now. You're dead to me, so peace out. Remember, you just freaked out. You ready for defeat now? I'm gonna make you bleed. Listen, I'll repeat now and read out all the week now. Get up and make a change. Don't remember yesterday. Hey. 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 Ain't nobody gonna change. Everybody stays the same. So be different, make a name, huh? Keep on moving forward. I was getting closer, marching till it's over, and just like a soldier, I keep on moving forward. I was getting closer, marching till it's over. All right, so we're gonna kind of let that ride. So hopefully you attempted these on some level, and I'm just gonna kind of work simultaneous. I know it's not the full 5 minutes, but that's okay. All right, so the first recommendation is when we're doing these evaluations, the first thing is you want to do is replace each x with a blank set of parentheses, okay? And we got this, x squared minus 6x plus 8. All right, okay, let me, copy, all right? So now for the first one, our x is what, 3, right? So then we just plug 3 into the blank parentheses. Okay, right? So then we'll get 9 minus 18 plus 8. Let me see. Negative 10, so that's negative 1, it looks like. Okay, for B. So for B, let me see if I want to see something. If I can, I want to see if Desmos can solve it, and if not, I gotta work around. Let me see. Let me see. I think it might be able to. I might have to Google how to do it. Let's see if I do g of x. We got x squared minus 6x plus 8. Okay. And then what if I type like g of, let's do g of 3. Let's do g of negative 2. Do y'all see that? It worked. Oh, snap. Oh, that's a game changer right there. Okay. Do y'all see that? You see how easy that was using Desmos, right? Again, I got this from the students. The students have been using this for like years over, each term. And so the one that was introduced to me was GeoGebra. And I just intuitively just typed the original function. And then in the next line, I put in the one I wanted to evaluate. So I'm just going to use that, right? And this is free. G of negative 2 equals 24. Okay, let's try C. This is what we got. Now for C, I want to showcase something else, right? We can do Desmos.
Bro,
hey, Google, stop.
No, we don't.
Oh my God. All right, so
All right.
long story short,
So the other thing I
allegedly,
like to
a
showcase
nigga from
is the
Morehouse
TI
was
83
raping a girl from
Plus.
Clark. Allegedly.
Man, I'm liking this
Allegedly,
music. Like this is some
that's
good
what
workout
happened.
music.
Yes,
So
I'm
yeah,
gonna
if you
say
want to hear like
because
music you probably hadn't heard
you
before,
never
I'm on
know,
like
right?
YouTube music, and I typed in no
Because
copyright music and
she
like
could be
gaming.
lying, or it could have got
And
to the,
so
or she could
the
have
music is
consented,
usually
and then it
pretty
got to the
good,
group
and
chat,
I've
and then
usually never
it
heard
said
from
something
her before
different,
because it's
and
like,
then a whole bunch of
just
stuff.
random artists. It's not like mainstream. So anyway, it's just
Exactly.
something
You
interesting.
feel me?
Okay.
So I'm not
So now
gonna,
we can do something
I'm
similar
not
in the
gonna
Texas Instrument, right?
automatically
So in the upper
assume
left-hand corner, I'm going to go to my y
it's
equals.
what
I'm
people
going to
saying it
type
is.
my
But
original
here's my
function,
thing,
x squared
Casey.
minus
I seen you at the party
6x.
acting a
That's not
fool
a
the other
6.
day. Hey,
6x plus 8. Okay, I'm going to go back to the home. Now, kind of in the
I
center of the
really didn't
calculator,
see you.
left
I'm
of
not
the
gonna
button
lie.
clear is a button that says VARS,
No,
which is short for, I think, variables.
I didn't. I didn't go up to y'all.
I clicked on that button. I'm going to go to the right to go to Y variables.
Well, okay. I didn't want to get lost from the people I was with.
I'm muted.
I didn't want to get lost from the people I was with.
Oh, no, you guys are muted. Sorry, yeah. Let me see. Oh, you guys can hear, but I can't. Okay, let me, I can fix it here. Close. Okay, good. Yeah, it's no worries. Okay. But yeah, so we went to Y variables, and then I'm gonna click on number 1 for function, and then number 1 again to call in the function that we typed in. So now I want to evaluate this function when x is a half. So I'm going to put 1/2, and then I'm going to hit math as a fraction. So 21/4 is correct, right? So then g of a half, 21/4, okay? So we saw 3 different ways to evaluate the first 3, right? We did the first one by hand. We could have did the second 2 by hand each. The second one we put in GeoGebra is intuitive, and I did a showcase on a Texas Instrument, right? So hopefully you've been able to generate some of these results. Let's work on D and E. What's my time? Okay, I'm watching the clock. Oh, come on. Let's duplicate and duplicate. I'm gonna turn the music down. Let me see, clear. And where is it? Clear. Okay. We're here. All right, cool beans. Battery's getting low. I don't know where my adapter is. Not gonna worry about it for right now. All right. So then for D. So G of A plus 2. Can I paste? Nope. Let me copy this. Copy. Paste. Come on. Paste. All right. So then we have our x squared minus 6x plus 8, okay? And again, in this example, our x is now a plus 2, so we're replacing each x with the blue thing. Okay. I think I might go forward. Yeah, let's keep going. So then the next line, so that first expression or that first term, we need to expand it out. So we have a plus 2 times a plus 2. Basically, we FOIL, right? So if we FOIL 4a plus 4, here we're going to distribute the 6. So minus 6a minus 12 plus 8. Then I think we combine like terms. Let me see, like terms. These are like terms. So they add up to what? Negative 2a. And I think these guys cancel each other out. This plus this is 12. Minus 12 is 0. Okay, so for D, we got that result at the bottom. E, I'm going to leave as an exercise, just in the interest of time. For E. And again, the details, they're here in the notes and they're on my in the recordings. All right, so you can get it there. Right now, I'm not able to load the notes in the box. I emailed an administrator for them to unlock it so that I can get back to my normal operations. It's been working for years, and now they're constantly doing updates and changing things. And so I guess in whatever latest update they did, it got disabled, and I just need them to turn that feature back on. Let me see. If the domain of a function that is defined by an equation is not explicitly specified, then we take the domain of the function to be the largest set of real numbers that result in real numbers as outputs, right? So, unless the domain is specified, we take the largest domain that generates real numbers, right? That's essentially what's going on here. Okay. Yeah, let's take a moment here. So now, for our purposes, I want to say there are two main cases for like unique domains that we kind of need to be aware of. The first is when we have rational functions, and the second is when we have like an even root, like square root, right? With rational functions, the domain in general is going to be all reals except any x that makes the denominator zero, right? Because it's like a fraction. When it comes to fractions, we can't divide by zero, right? So in general, for a rational function, i.e. like where you have like a fraction, the domain is all reals except any x that makes the denominator zero. When we take in the square root, right, what kind of numbers can we not take the square root of? Just take a moment. Can somebody in the chat tell me like what kind of numbers can we not take the square root of? Negative, right? Yeah. We can't take the square root of negative numbers. So in general, for like an even root radical, like square root, fourth root, stuff like that, sixth root, the domain is going to be basically the radicand, the part inside the radical has to be non-negative. In other words, has to be greater than or equal to zero. Okay. I'll do like a couple of these guys. So like for instance, the first one, it's a rational function. So the main thing is we have to throw out any x that makes the denominator zero. All right. So for A, what we're going to do is set the denominator to zero and solve. We can add x squared on both sides, or we could factor. When we go to take the square root on both sides, plus or minus one, right? So our domain is going to be all reals except plus or minus one. All right, because if we let x be one, it generates a zero in the denominator. If we let x be negative one, it generates a zero in the denominator. I'll do B right now. I feel like B is light. Actually, I'm going to do D. I'll leave B and C as an exercise. Man, you were like going in hard, like for no reason on this one. Can we skip this one? Yeah. Anyway, I know there's a way I can go straight to the next song, but that's okay. I can't get it to work. Okay, so for D, right? So we said with square root, we got about 5 minutes left in class. So whenever there's an even root, we can't take the even root of negative numbers. So the radicand, which is the part inside the radical, this guy needs to be greater than or equal to zero. Okay. Let me see. So to solve an inequality like this, we treat it like an equation. We just have to be on the lookout if we multiply or divide by a negative, right? So it looks like maybe we can factor this guy. Because the second sign is a negative, our signs are going to be opposite. We're looking for two numbers that multiply to give us -3 and add to give us a +2. I think it's a +3 and a -1. So it looks like our critical numbers are what? -3 and 1. Okay. And then, so basically, really what we should do is do a number line. This is a little bit excessive, but I think this is what we have to do. And the shape of this is a parabola, and we're trying to see, okay, when is this U-shaped curve above the x-axis? So we should choose, like, for instance, when x is -4, we should choose a point here. Like, for instance, this is like region A, this is region B, and this is region C. We need to choose a point in region A to test, choose a point in region B to test, and choose a point in region C to test. So, for instance, when x is -4, all right, this guy is negative. This guy is negative, and negative times a negative is going to be positive. So when x is -4, our function is above the x-axis. It's positive in this region, okay? If we choose a number between -3 and 1, like I think we can choose 0, and that'll be okay. It looks like if we let x be 0, we get a negative result there. So our graph should be entirely below the x-axis between -3 and 1. And if we choose a point in region C, like when x is 2, this guy is positive. This guy is positive. Positive times a positive is positive, right? Okay. So if you think it's like a U-shaped curve where we start above the x-axis, we cross at -3, it turns, then we cross back at 1, and we're going back positive. So now we're saying, when is this graph above the x-axis? So now we can clearly see, oh, it's above the x-axis, left of -3, and right of 1, right? So ultimately, the domain there is going to go from -infinity to -3, 1 to infinity. Infinity always gets parentheses. Because we can be equal to 0, we're going to use a square bracket there. So that one was a little bit involved, right? A little bit involved. That's going to take practice to kind of work out these details. So you have to dig and ask questions and collaborate, work with tutors, ask me questions, stuff like that, for things like this. Okay, so we got about a little over 2 minutes left. Let me kind of do a scan. And so make note of how they're writing their interval notation. This is how we write everything except plus or minus 1, right? So interval notation. Okay, I'll let you kind of check that later for those. I'm going to have to rely on my recordings for this one. My battery is getting low. Okay, yeah, I know. Okay, I'm going to have to rely on my recording, and you have it here. I didn't try to get you a copy. Now, the vertical line test is what we were doing earlier. So where we were saying, you know, when we look at the graph, if we ever have points stacked on top of each other, then it's not a function. That's essentially the vertical line test. So if we're given a graph, and if we can draw a vertical line and it touches the graph more than once, then it's not a function. Let me say that one more time. If we have a graph and we can draw a vertical line and it'll touch the graph more than once, then it's not a function. In other words, no matter where we draw a vertical line, it should touch the graph only once, then it is a function, right? So like if you look at this example, you could find some points stacked on top of each other, so that's not going to be a function, right? So on and so on. So these are fairly light. I think you can handle these, you know, doing a showcase of the vertical line test, okay? If you need an explanation of these, I'm going to have to refer to my recording. Same for this one. This one is a little involved. You definitely want to take some time to go through these examples, okay? It just takes some time. Again, the recordings are there. All the things I want to say is already there. Okay. All right, that wasn't too terribly bad. Are there any burning questions before we go our separate ways? I'm going to remove my microphone, so if you need to unmute yourself, you can. Let me see. So, yeah. Let me see. So, I'll get a copy of this to you all as soon as I can. Again, somehow, for some reason, the admins like disable what I was doing, and so I have to either try to get them to turn it back on or find some other way to distribute out this information. Aside from that, so on Wednesday, we'll take some time to go through as many of the homework questions from this section together as we can. Wednesday is a good day to like ask questions. Like if you are stuck on the homework problem or if you can't figure something out, that's a good day to kind of ask questions. The exam one, you can anticipate it to become available this upcoming Sunday.
and you can earn up to 100%, or you can earn full credit for 7 days. After the 7 days, then it's due. If you submit it past the due date, the highest you can earn is at 95%, which is still pretty much, decent A. The hard deadline for all assignments at the end of the semester. If there aren't any burning questions, we're going to go ahead and end the session here. And I will meet back on Wednesday. And from one beautiful mind to another, enjoy the rest of your evening, gentlemen. Take care. Peace. So, and I got another class that meets in 15 minutes. I'm going to stay on the line and just mute myself. But you guys are free to go. I'm just waiting for my next class to show up.
Professor C, I have a question.
Yes.
But the bookstore just gave me my my textbook with the math lab access.
Okay.
So the first couple assignments are going to be late.
That's okay. It's nominal.
Okay.
Like,
Thank you.
if you're close at the end, I'm not gonna. I'll make sure that you. I'm not like, if you're like a fraction of a point from a letter grade, I don't do that. So
All right.
just as long as you get them in soon, you'll be fine.
Yes, sir. Thank you so much.
Uh-huh. Kind of let the music run, but I'm not gonna do that. Let's see if that works. How can I get that from here to here? Okay, maybe. Assignments that are turned in late still get graded. Yes. Yeah. You still need to submit them. Yeah. Yep. You can still earn up to 95% on them. Let's try this. Yep. Oh, you're gonna stop? Thank you. I was like, you should at least be fun. Hmm. Let me do both.
You said that you feel lonely. Hard to get to know me, but better than the lies. No way I'd let you slip by. No way I'd let you say bye. You said there ain't no reason, but I'll sit here every day, waiting for the moment I won't feel like I should stay.
Testing. Okay, cool.
You are in every dream and everything I lay my eyes on. What are you looking for when you look at me? You gotta know. I was never
All right, gentlemen. So, let me get to the right folder, right file. Okay, let me make sure. Well, it can't be right. Oh no, did I open the wrong one earlier? Why is this like this? Not a function. Oh no. I think I did open the wrong one earlier. Let me see this one. That's so strange. That's weird. Shiesta. I don't know why. Yeah, that's really strange. I don't know how and why I did that. Let me reboot this. Maybe if I reboot it, that'll fix it. Okay. No, I don't want to get tickets now. I'll just get it later. I don't want this. I'm coming, gentlemen. When I went to open our notes for the day, I don't know, it was acting weird, so I just rebooted it. Okay, I think, yeah. Yeah, I don't know. I rebooted it and it seemed like it's working now. That looks proper. Okay. View. There's a single page. Okay, so let's do I wanted to say I have this urge to say morning announcements, but it's not morning announcements, it's afternoon announcements. Let's see. So one, I hope everyone had a great weekend, right? So we kind of had a short week last week because of the Labor Day holiday. Yeah. So, just to kind of as a friendly reminder, the main things that I'm looking for from each of you, basically get your attendance credit, homework credit, and I think this section has a lab component associated with it. So just make sure that each of you are doing your lab. The lab is a separate course or facilitated by my colleague. So, it's Dr. Lamar. So just make sure that you follow her instructions. And basically at the midterm and the final, she'll give me a grade for each of you that I'm going to scale. It counts as 10% of your overall grade for us. So as far as attendance, two things there. So first, just make sure that when you log into Zoom, it's showing your student name. So your first name, last name. In one of my group courses, I have some student that kept using Zoom user, so they weren't getting their attendance credit. Right. So you don't want to be in that boat. You don't want to show up and not get credit. Right. So again, to get your attendance credit, make sure that your Zoom username is showing your student name, and then you just show up to these sessions. Now, I try to go out of my way to not hound you guys individually, or I try not to single people out. So if I'm not going to single you out, then really you just show up and zen out, right? I think that's reasonable. I used to try to single people out, but it was too much. It was just too much for me. I was like, this is a waste of time and energy. I don't mind like kind of going back and forth and like answering questions and things like that, but sometimes trying to get you guys to talk was like giving me a headache. Also with today, I am using my microphone, so I can't hear your audio, but I am monitoring like the Q&A and the chat. So if you have questions, feel free to either type it in the Q&A or the chat. And so today we're going to be working on section 1.3 functions. So what that means, this is our third section that we've done together. So what that means is basically next week you can anticipate exam 1. I think it becomes available this upcoming Sunday morning, like 11 a.m. And then for 7 days, you're going to earn up to 100% credit. So it's basically due 7 days later. And then if you submit it late, there's only a 5% late penalty. So even if you submit it late, you can earn up to 95%. And then with all of our assignments, we get unlimited attempts. Okay. And again, if you have questions, feel free to either type it in the chat or put it in the Q&A because I don't have headphones. I just have a microphone, so I'm not going to be able to hear your audio for right now. Maybe at the end of class, we'll have an opportunity. If you need to like speak audibly, you can. Okay. So again, for today, we're going to be working on section 1.3 functions. And again, we'll get through as much of this together as we can. None of my classes have had enough time to kind of get all the way through all the examples. So whatever we don't do together, I do expect you to use my my pre-recorded lectures on my YouTube channel, to watch those. And I go through it's the same material. I'll go through all the details. So we're just kind of doing this to fill the air. Okay. And so with section 1.3 functions, we have a few objectives we like to touch upon. 1, use functional notation and find function values. 2, find the domain of a function. 3, identify the graph of a function. 4, get information about a function from its graph. 5, solve applied problems by using functions. Okay. So we have some definitions. A special relationship such as y equals 10x, in which to each element x in one set there corresponds a unique element y in another set, is called a function. Y is sometimes referred to as the dependent variable and x as the independent variable. Excuse me. So the main takeaway here is that every x corresponds to exactly one y. Okay, we don't have the case where one x corresponds to more than one y value, right? If one x corresponds to more than one y value, then it's not a function. Okay. A function from a set x to a set y is a relation in which each element of x corresponds to one and only one element of y. The set x is said to be the domain of the function, and the set of those elements of y that correspond or assigned to the elements of x is the range of the function. So what we're doing is like, we have our set of input values. We're going to pass them through our function and generate a set of output values, right? So that's essentially what's going on. Our set of input values is called our domain. Our set of output values is called our range. Okay. So for each x in the domain of f, that corresponds a unique y in the range, right? So every x corresponds to one y. The number y is denoted by f of x and is read f of x or f at x, right? So, and we call f of x the value of f at the number x and say that f assigns f of x to value to x, right? So this symbol here, this is a f of x. A common error that students tend to do, they'll see this and they'll think, oh, we're multiplying by x. We're not, this is not multiplication. We are not multiplying by x here. Again, what this guy means is the function f evaluated at the value of x, all right? F of x. Again, a common error is that students will try to multiply or distribute to x. So this is not multiplication. That's not what we're doing here, okay? We're evaluating the function at some given value of x, okay? So functions can be defined by ordered pairs, tables and graphs, and equations. Okay. So in this example, we're asked to determine whether each relation defines a function. So each relation is just a set of ordered pairs. In this context, if we have any repeating x's, then it's not a function. So I just take a moment, like a few seconds, like let's do 15 seconds. Are there any repeating x's in A, and is it a function or is it not a function? You can type it in the chat. Are there any repeating x's? So, and it, is this a function or is it not a function? All right. So hopefully you see that there are repeating x's, this guy and this guy. So that means this is not a function, right? because we have repeating x's. If we were to plot these ordered pairs, they would be stacked on top of each other, right? And then can anybody identify the domain of this guy? Just in the chat, what's the domain? Right. So the domain is going to be our set of input values, the unique input values, no repeats, right? So where we have 2 1s, we would only write it once. Our range is going to be our set of output values, right? Okay. Our range is our set of output values, sorry, the unique ones. Okay. And then same question with part B, is this a function, yes or no? In other words, are there any repeating x's? Is it a function? Are there any repeating x's? Notice that there are no repeating x's, so then it is a function, right? It's kind of like in life, if you're constantly going back to your x and that's a little bit dysfunctional, maybe not, I don't know. But, in this context, if we have repeating x's, then it's not a function, right? Okay. And again, the domain is our set of input values, the range is our set of output values. And I think we have it here. And so, I went to share my notes with my students earlier, and it was kind of locked out. So right now, I don't know that I can share these with you, but again, a copy of this, you can like screenshot this, and I'm going to get a copy to you. I'm just trying to get them to whatever feature they disable. I'm trying to get them to put it in it, re-enable it, so I can go straight from here to where you guys can access it. Okay, and then for part B, right, this is what we got. Okay. So I think in the original notes, we had a typo. So I think we corrected it. Determine whether y is a function of x for each equation, right? For part A, let's see. So for part A, we have originally I think it had minus x, but I think that was a typo. So we replaced the minus x with supposed to be a minus 3y. And we want to see, can we write y as a function of x, okay? So it's a couple of ways we can go about evaluating this. Remember, we said that if any points are stacked on top of each other, then it's not a function. So first, let's see, can we write y as a function of x? In other words, can we solve for y? So here, let's take 3 minutes. Let's take 3 minutes and you can try both of them actually in that 3 minutes and see if you can write y in terms of, can you solve for y in either case, right? Let's take 2 minutes. Just take a couple of minutes to see if you can solve for y in terms of x. Hopefully, I'm gonna put some music on. Hopefully it's not gonna be too terribly loud. How is it going? Okay, I think it's gone. But yeah, just take a couple of minutes. So we'll check back at like 3:14. Man, why is like everything getting signed out? Yeah, that's what I was listening to.
You are in every dream and everything I lay my eyes on. What are you looking for when you look at me? You gotta know.
And let's take 30 more seconds.
I was never young.
20 more seconds. I would let the music keep going if I can control the volume of it, but I don't think I can adjust the volume here and the way I have it set up. So I'm just gonna stop it. Okay. So at least, hopefully, you took a moment to at least start on these, even if you didn't finish. You thought about it for a little bit. Let's take a look at A. If we wanted to solve for y, we could. I think what I'd like to do is like add 3y to both sides and subtract 12. So if I add 3y to both sides and I subtract 12, I'll get this, right? Then maybe divide both sides by 3. 2x squared minus 4, right? Notice we have y in terms of x. No matter what x value we choose, each x corresponds to exactly one y. We don't have one x corresponding to multiple y's, right? So this one is a function. I'm going to give you a further explanation there, or we're going to say yes, a function. Okay. I'm going to come back to this and give a little bit more detail there. Let's go ahead and kind of see if we can solve for y in terms of x in part B. So if we wanted to solve for y in terms of x, maybe we can add x squared to both sides, and we'll get this guy. Okay. And then to get rid of that squared, if we're trying to get y in terms of x, we can take what? The square root on both sides. So square root here, square root here. Now, whenever we introduce square root, right? Hopefully you're thinking about a certain symbol that we need. Whenever we take an even root, we need to include plus or minus, right? This guy's going to cancel this guy. So this gives us y equals plus or minus the square root x squared plus 4. Okay. So notice that each x here corresponds to more than one y. For instance, when x is 0, 0 squared is 0, plus 4 is 4, square root of 4 is 2. So when x is 0, the corresponding y is plus or minus 2. So because each x corresponds to more than one, or because we have at least one case where an x corresponds to more than one y, this is not a function. Okay. Another thing that we could have done was look at the graph. Okay, so I'm gonna use Desmos. I'm gonna do a Desmos demo. Okay, so this is fine. Basically, when you log into Desmos, you click on Graphing Calculator, it'll bring you here. So like, for instance, for the first one, I'm just going to type it in as a C at 6x squared minus 3y equals 12. 6. Come on. Why are you not working? There it is. 6x squared minus 3y equals 12. Okay. So in the first one, we get a parabola, right? We get a U-shaped curve. Notice that we don't have any points stacked on top of each other, right? Every x corresponds to exactly one y. So that's why this one is a function, right? So now let's try the second one. We have what? Y squared minus x squared equals 4. And we get an image like this. Notice that we have points stacked on top of each other. So that's why this one is not a function. Every x does not correspond to a unique y. Every x actually corresponds to 2 y's in this case. All right, so this one is not a function. Okay. And so the giveaway for part B was because of the plus or minus, right? When we see that plus or minus, it's not a function. That means one x can correspond to more than one y. Okay. Let g be a function defined by this equation. Originally they had y equals x squared minus 6x plus 8, which is fine, but because they want g to be a function, I just wrote it in function notation in terms of g, right? So it's the same thing, I just changed the notation a little bit. Evaluate each function value. Okay, what's the time? I want you to take let's take 5 minutes. Take 5 minutes and see, and try to see if you can how many of these answers can you generate, right? So we'll check back at 325. And so for the first three, we're basically just plugging in, right? So replace the X with those values, and you should generate some results. And then see if you can do D and E. Yeah, so just take some time and take those as far as you can. And I might get started a little bit early before the 5 minutes is up.
You are in every dream and everything I lay my eyes on. What are you looking for when you look at me? You gotta know. I was
I would never wait for something to let it go to waste. With everything at stake, not that I would take it all back. I just wanna make this thing last, but we're running out of time.
All right.
We
So,
were
I acknowledge it hasn't been 5 minutes, but are there any brave souls that would like to did anybody get any results for any of these that they be willing to put in the chat? Anybody get any results here? Or anybody got anything? Okay, so let's take a look at this, right? So I want to showcase a few different ways that we can go about this, right? So first, we'll just do it by hand, right? So for instance, for part A. So G of 3. Now, the first recommendation is whenever we're evaluating a function at a number, at a value like this, first replace each X with a blank set of parentheses, and then write your number into the blank parentheses, right? So we got this equals X squared minus 6X plus 8, right? And our X in part A is going to be 3. Okay. So it's going to be what? 9 minus 18 plus 8. I think it's -1. Okay. So the second showcase that I like to do, I want to showcase, we can actually evaluate functions like this in our TI-83, in our Texas instrument, right? So suppose we want to evaluate G of -2. Now, first you might try doing this by hand. Let's see. Let's see how to do this in a Texas instrument. Okay. All right, so what I'm going to do, on my upper left, I'm going to go to my y equals x squared minus 6x plus 8. So I just typed that in as it was given. Now I went back home, and then kind of in the center of the calculator, left of the button that says clear, is a button that says VARS for variables. So I'm going to click on that button. I'm going to go to the right to go to y variables. I'm going to click on number 1 for function, and number 1 again to call in the function that I just typed in. So I put an open parentheses, and I want to evaluate this function when x is -2. Okay. We got a result of 24 there. And you could confirm, you could do it manually. All right, and confirm you get the same result. And then for C, we want to evaluate g of a half. Okay. Now, before when I did this with in my Texas Instrument, but I want to showcase this one in okay. So if I wanted to evaluate this in Desmos, maybe I'll type my original g of x equals x squared minus 6x plus 8. So that plus 8. That's not 8. Okay. I hit enter, and I want to evaluate g of 1/2. Is there a way? Can I do this as a fraction? Here it is. Yeah, we got it. Nice. Right? So we were able to generate a result as a fraction. All right. So for all I did, I put my function g of x essentially as given. And then in the next line, I basically type g of 1/2. And there was a little option kind of in the left-hand side there to put it as a fraction. And so we got 21/4. And again, this is a free utility. This is called Desmos.com, a free graphing utility. So, evaluating a function, it's able to do it, right? So it's free. That's equal to 21/4. It's my time. Okay. We're already halfway. Party's almost over. What a bummer. Anybody know where I got that from? I'm just curious. It's an obscure place. You wouldn't necessarily know it. All right. So that was those examples. This thing is acting up again. Come on. Oh, let me just duplicate this. Duplicate right here. And what I'm going to do is get rid of these guys. At least try to. All right. So we saw 3 different ways of doing A, B, and C. Okay, so for D, I want to see if Desmos can do that one as well. All right. A plus 2. So now we want to evaluate g of a plus 2. How can where is it? Do I need to refresh? There it is. Okay. So let's see if Desmos can do this one. G of a plus 2. Add a slider. Maybe not. Nope. Nope. Okay. All right. Well, I was just testing it out to see if we can do that. But it can at least, and maybe if I dig a little bit, maybe if I research, I could find where it might be able to expand that guy. For right now, we're going to do this one by hand, or we're going to do it manually. Okay. So for D, g of a plus 2. So first, we're going to replace each x with a blank set of parentheses. Okay. And again, we're evaluating each x at a plus 2. Okay. So I think that first term we need to FOIL. We'll get this. The second term, it looks like we need to distribute a -6. Okay. Then I think here we combine like terms. Now I think a squared is unique, so there's only one of those. We got 4a and a -6a to give us -2a. And then 4 plus 8 is 12. Minus 12 is 0. Nope. Okay. All right. All right. And then for E, I'm going to leave it for you to find out on my recording. So I'll leave it as an exercise. Okay. But you definitely want to take a look at that explanation. It's a little bit involved, so just take a look at it and give it a go. Maybe attempt it just on your own first, and then once I'm able to get you a copy of these notes, the solution is here, or you can use my recordings. Okay, let me check on you guys. Okay, you look okay. So we have this agreement on the domain. If the domain of a function that is defined by an equation is not explicitly specified, then we take the domain of the function to be the largest set of real numbers that result in real numbers as outputs. Right. So if no domain is specified, then we just take the largest domain that generates real number outputs. Okay. So with that, we want to look at this example on finding the domain of a function. There are two special cases in finding the domain that we kind of need to talk about. The first one in part A is finding the domain of a rational function, right? So it's kind of like a fraction. When it comes to fraction, what number is it that we have to be on the lookout for that we can't do, right? And a hint, this number has something to do with the denominator. What number is it that we have to be on the lookout for when we're working with fractions? It's restriction. Like what restrictions do we have? We cannot do what when it comes to fractions? Anybody? Nobody? All right. So when it comes to fractions, and I know you know this, I don't know if you guys are actually here or not, but yeah, when it comes to fractions, we cannot divide by 0, right? We can't divide by 0. So with that, whenever we have a rational function, we need in general, the domain is all reals except any x that makes the denominator 0. Okay. Okay. So when it comes to rational functions, again, in general, the domain is all reals except any x that makes the denominator 0. Okay. So I'm gonna leave the rest of it as an exercise for part A. For part B, I do want to mention something there though. So for part B, we're working with the square root function, right? Can anybody in the chat tell me what kind of numbers can we not take the square root of? All right, what kind of numbers can we not take the square root of? Now we can take the square root of 1, right? Because the square root of 1 is 1. Because 1 squared is 1. Try again, but you're close. You're almost there. Nah, we can take the square root of 10. It might be irrational. What type of numbers, though? What can we not take the square root of? And 10 is going the wrong direction. That's another hint. There it is, right? I know you guys know this. All right, we can't take the square root of negative numbers. All right? So when it comes to the domain of a radical, like an even root, like square root or fourth root, sixth root, eighth root, anything like that, whenever we're taking the square root in general, we can't take the square root of negative numbers. So in other words, the radicand needs to be greater than or equal to 0, right? So I'm going to leave that part as discovery for you. If you want to see these worked out, like from me, it's in the recording for this section. It is a good idea to try these on your own. Again, let me kind of recap this real quick. For rational functions, in general, the domain is all reals except any x that makes the denominator 0. So we have to basically set the denominator to 0 and solve. We have to throw out any x that makes the denominator 0. When it comes to taking an even root, like square root, like you see in these examples, we can't take the even root of a negative number. So in other words, the radicand has to be greater than or equal to 0. The radicand is the part inside the radical, okay? That's if we're working with square root, fourth root, sixth root, eighth root, so on and so on and so on, right? Okay, and these get interesting. Like each one of these has its own little nuance, but I think I want to leave it for discovery for you all. You can have like I feel like at least the first two I feel like aren't too bad. Part C gets a little interesting, and D is a little involved, right? So you definitely want to check out those recordings. Again, my recommendation: try them on your own. See if you can generate the interval, the domain of these, and the interval notation for each one, and then maybe you might kind of compare it to this. Here are the results, okay? And then if you need an explanation, it's in my recording, right? I'm going to leave those as an exercise discovery for you. We got a solid 10 minutes. Okay. I don't mind doing this one. Like I think you guys are the first group today that I made it to this point with this amount of time. So we'll go ahead and give this one a go. So given this f of x with this domain, first we're asked, is 10 in the range of f? Is 10 in the range of f, right? So if we want to identify the range, what we could do is like evaluate the endpoints, and notice, so the original function is a U-shaped curve, right? It's a parabola passing through the origin. And we want to get the range as x goes from 3 to 5. So it's going to be monotone. So it's not like changing direction or anything in between 3 and 5. So then we can just plug in the endpoints, right? Okay, and then do an analysis. So I'll go ahead and do it now. So for part A, let's plug in when x is 3, right? So that an f of 3 is going to be what? 3 squared, which is 9. And then I guess we don't need this. And then let's evaluate f of 5. It's going to be 5 squared, which is 25. So then we can say our range, our y values, are going to go from 9 to 25. So is 10 in that range? We would say yes. Okay, that's the result that we got just now. Okay. Is 4 in the range? Well, we got that the range goes from 9 to 25. So it's 4 in the range, we would say no. Okay, chance favors the prepared mind. Now we could guess. If we were to guess, it's a yes or no question, we would have the 50% chance of getting it right, 50-50. But chance favors the prepared mind, right? You boost the odds of success in your favor. How do I used to finish that? I guess by doing the homework and like practicing, by being prepared, right? Anyway, so we got to know there. Find the range. Okay, well, we already found the range. Okay. All right, let's see how do we do. So this is just us doing it on the first pass. Okay. Oh, okay. So what they did for part A, they set y equal to 10 and then work backwards, right? To see what x value they generated. Let's give that a go. I want to try that. So if we let y be 10, right? So we got what? X squared equals 10. If we take the square root on both sides, x is going to be what? Plus or minus the square root of 10 is what? Between 9 and 16, so it's like 3 point something, right? Now the negative is outside the domain, but the positive is inside the domain, right? So in other words, we can find some value of x in our domain that's going to produce 10, right? Again, we would discard the negative in this context because that will be outside, but the one that we would use, whatever the value of square root of 10 is, it's like 3 point something. Okay, because the square root of 10 is between 3 and 5, right? 3 point something. The number is in the interval, so f of x equal to 10 has at least one solution in the domain. Therefore, 10 is in the range, right? So we can find some value of x between 3 and 5 that'll produce a value of 10. For part B, is 4 in the range? No, square. Let me see. Square root of 4 is going to be 2. 2 is outside of this domain. So that means that 4 is outside of our range. Okay. And then to find the range, it looks like let's see. Oh, they wrote, that's weird that they did it that way. I don't know why they did it that way. But yeah, we had already found it, right? I think we plugged in the endpoints and kind of worked it that way. Okay, that's fine. Okay. Okay, let me mention something here with the vertical line test. So earlier, when we introduced functions, we said that if we're looking at a graph and if we have points stacked on top of each other, then it's not a function, right? So what that was is actually this thing we have called the vertical line test. If we have a graph and we can draw a vertical line and it touches the graph more than once, then it's not a function. Okay. In other words, no matter where we draw a vertical line, if it touches the graph only once, then it is a function. Okay. So in this example, you should see where 2 points are stacked on top of each other. If we can draw a vertical line somewhere and it'll touch the graph more than once, so this one would not be a function. I think I left these pretty much as exercises for the earlier students. Okay. So these explanations are not too terribly bad. That's the only reason I'm comfortable skipping. All right. Then we're gonna go ahead and make this the last one for the day. So then for part A, okay, we're given this function, f of x equals x squared minus 2x minus 3. And again, those images before, those were all showcasing the vertical line test. So you can either try it yourself with the solution is there, and you can, make it make sense, or you can use my recording. We got like maybe a little over 3 minutes remaining, so that's why I kind of went through it. And plus, it's not too terribly bad. I mean, it's not a difficult concept to get. You'll get it fairly easily. So given this function, is this point on the graph, right? So when x is 1, does it generate -3? Let me see. 1 minus 2 is -1. Minus 3 was like -4. So is this point on the graph? For part A, we would say no. Okay. Find all values of x such that x, 5 is on the graph. So what value of x will produce a result of 5? So in other words, we want to set y equal to 5 and solve. So then we have this x squared minus 2x minus 3. We want to set it equal to 5. Now to solve this guy, I'm going to set it to 0. So subtract 5 from both sides. We get a -8 equals 0. Can anybody tell me what is this technique that I'm attempting to do? What is this called? What technique is this called? So this is one of those concepts that we do expect you to already have some level of command. You will get some support with this. Yes, it is factoring, right? You'll get support with factoring in the lab. If you need additional practice on factoring, I think I have some handouts in our box folder. And if you open up box, you're going to see something that says handouts, and then you can find some additional practice there. We're looking for two numbers that multiply to give us -8 and add to give us 2. Is it -4 and 2? Let's see if those work. -4 and 2. Yeah, right. So then if we solve this, I think we get x equals -2 and 4. Okay. So what we're saying is that if we let x be -2 in the original, it should generate 5. If we let x be 4 in the original, it should generate 5. Let's see. That's going to be a 4 plus 4 is 8. Minus 3 is indeed 5. So the first one checks out. We can check this. The second one, 16 minus 8 is 8. Minus 3 is 5. So both of these will generate 5 in the original. Okay. I'm watching the clock. We got just shy of a minute remaining. Let me see. Fine. Been a little bit OCD here. Give me just a moment. I know we're short on time. Darn it. Okay. Find all wire intercepts. Okay, so if we wanted to find a wire intercept, then we set x equal to 0. Okay, so if we set x equal to 0, you should quickly generate the result of -3. So the wire intercept will be -3 comma 0. That's not right. We set x equal to 0, right? Okay. And then for our x-intercept, we set y to 0. So if we set y to 0, we'll have x squared minus 2x minus 3. It looks like more factoring. Okay. So that's where our lab and digging and asking for help, and that's where it comes into play. That's enough, reviewing those concepts. Let me see. It should be a plus and a minus. We're looking for two numbers that multiply to give us 3, add to give us 2. So it's a -3 and a 1. So then x equals -1 and 3. Let me just check it real quick before I move away from it. That's going to be a 1 minus 2 is -1, -4. Uh-oh. Let me check that again. It's a -3. It's a -2. That's a 1. Oh, okay. 1 plus 2 is 3. 3 minus 3 is 0. Okay, that checks out. 9 minus 6 is 3 minus 3 is 0. Okay. So these results check out. Okay. Let me just wrap this up so I can get you all out of here. So again, we have the prepared notes. Okay. So you can confirm. Yeah, we got a no there. Okay, so the notes are there. And then I think there's one more example. So again, if you want those details, it should be in my recordings. Okay, so are there any burning questions before we go our separate ways? I'll get a copy of this to you as soon as I can. I just got to get that feature unlocked by the admins, and I don't know how long that's going to take. And again, this content is available in my recordings. Are there any burning questions going once? Hang on, I see something. Yeah, that's cool. Okay, any burning questions going once, going twice? Let's see. Okay, so we have homework. We have a homework assignment and a quiz every week. So hopefully, that stuff is there. And then I think exam 1 becomes available this Sunday, and you can earn up to 100% for the first 7 days. After that due date, 7 days later, then the highest you can earn is at 95%. Okay. Any other burning questions before we go separate ways? Going once, going twice. Okay. Okay. So yeah. Again, so on Wednesday we'll go through as much of the corresponding homework. If you're stuck, that's going to be a great day to ask questions. During exam weeks, again, I kind of treat them like office hours. So maybe like that first day during exam week, I'll do a review session. And then that second day, like on Wednesday of next week, I'll probably just use it as unofficial office hours. I'll just check in with you all. If you have questions, you can ask them. You can even ask questions about your exam. You can take your exam during class if you want. And if you get stuck or if you have questions, you can ask questions. We get unlimited attempts on all assignments, and the system is set to take the highest score. So when the exam comes out this Sunday, give it a go, give it an attempt. And then if you want to take it during class, you can. If you want to ask questions, you can. We can. It's essentially we're like working on it together. All right. So if there aren't any burning questions, we're going to go ahead and end the session here, and we'll meet back on Wednesday at the same time, same place to go through some of the homework sets. All right, gentlemen. Take care. Peace.
Thank you.